Good morning, my dear 9th standard students. Welcome back to mathematics class. We are going to start a new chapter today, linear equations in two variables, and this is part 1. Remember one thing, even though we will be having physical classes, that is direct classes, these videos are very important. So you should continue to go through the videos, practice all the videos, because in the class we are going to only have a revision. We will have only summarizing, revision, or you call it as overview. We are going to see that only. So the videos are very important. You have to go through the videos in detail, practice all the examples. The videos are also prepared like that. It covers complete textbook, all the examples, all the exercises, plus additional information are also given in the videos, which you may not be able to feel, or you may not be able to, we don't have time to do all those things in the direct classes. So we will now continue with this chapter. We will start this chapter. Totally there are 11 parts in this chapter, and this is part 1. And this is introduction. So in the last video we summarized the entire chapter of coordinate geometry. Hope all of you remember what we studied in coordinate geometry, because we are going to use some of those coordinate geometry aspects in this chapter. When we go forward, I will explain to you how they both are, this chapter and the coordinate geometry chapter, are connected. In this video, we will discuss what all we will be learning in this chapter, recollect what is meant by linear equations in one variable, and some definitions related to the same. What are we going to learn in this chapter? Recollect what is meant by linear equations in one variable and some definitions related to the same. Understand what is linear equations in two variables. How to find solutions for linear equations. How to draw a graph of linear equations. This links linear equations and coordinate geometry. As I told in the previous page, this is where we will be seeing what is the direct link between coordinate geometry and linear equations, and what is the need for studying about linear equations. So mainly we will be covering three heads, that is, understand what is linear equation in two variables, then the solutions, then the graph. These are the three things we will be learning from this chapter. Equations in one variable and definitions. First, let us collect some definitions. Before going to what is one variable, we will go to definition. In an equation, the value which does not change for a given situation is a constant, and the value which varies for a given situation is variable. There are only two terminologies. One is called a constant, another is a variable. All of you know this, but still just we are starting this chapter so that you don't have to forget. Whenever you have any doubt in any of these definitions, you can always come back to this part and then you can understand the meaning. Let us see practical example, then you will be able to understand even better. P square, that is example, P square, perimeter of square equal to 4 into side. So if perimeter is 16, S equal to 4. If perimeter equal to 6, S equal to 1.5. If side equal to 3, perimeter equal to 12. So what are you seeing? Perimeter is what the answer we want, and we have an equation 4 into 7. In the 4 into S, in that 4 is the constant and S is the variable. Here the given situation is the perimeter, that is we want the perimeter for whatever is the square size of the square, but 4 is always same. But S can take any value, that is S is the side. We can find the square of 4 centimeter, we can find the square of 6 centimeter, side of 6 centimeter, like that. So the side dimension keeps varying. According to the variation in the side, the actual value of the perimeter will depend upon. But what determines the perimeter? It is the multiplication factor of 4. So 4 is a constant. Whenever there is any perimeter for a square, it is always 4. But it can be any different size, that is that which is depending on the side. So S is the variable, 4 is the constant. We will see one more example in the next page. We will see a practical example. If you have to make 12 students sit in a class, how many 3-seater benches are required? Now I would give you this question. Think about it. You can pause the video, note down this question in your notebook, and think what could be the answer. There are 12 students and there are 3-seater benches. You know 3-seater benches, where in a bench 3 students can sit. How many are required? Excellent. I am sure all of you would have got it. 3, that is 4. Answer is 4. But now I have written an equation, that is 3 into n equal to 12, where n equal to number of 3-seater benches. Answer is 4. What is the reason I am putting this equation? Straight away I can divide 12 by 3. The reason is there is a possibility the number of students will change, right? So let us see. Here 3 is the constant. Number of students in a 3-seater bench is fixed. That is, you cannot make more than 3 students sit in a bench, or we will, since we are telling 3-seater benches, we are going to make 3 students sit in a bench, not 2 students. That means this is not going to change for this situation. The situation is the number of students to be seated, and n is the variable. Number of benches changes depending on the total number of students, changes for this situation. Again, let's go to the next page. You will be able to even understand better. But remember this equation, 3 into n equal to 12. N is the 3-seater benches depending on number of students. That is, if there are 15 students, then the equation will be 3 into n equal to 15. That is, the number of students is the situation. That is what is required. In which case n equal to 5. So the n, what happened? The 3 remains same. See, there is no change in 3. But the n keeps varying depending on the number of students. So the number of students is what is, number of students to be seated in a classroom is the situation. Hope you are able to understand what is a situation. So the number of students to be made to sit in a class is a situation. For this situation, we have 3-seater benches. In 3-seater benches, we can make 3 students sit. So how many students are required, how many benches are required depends on the number of students totally available. But that 3 will not change because 3-seater benches can accommodate 3 students. So this type of equations with only one variable are called equations in one variable. That is, here there is only one variable, either it is a bench, or maybe you can even have some cricket teams where you can say number of teams required, so number of students per team. So like this you can have different situation. In all the situations where there is only one variable, only one particular aspect changes, the other one is a constant, is called equations in one variable. What is a linear equation? Let us recollect what is meant by degree of an equation. Before going to linear equation, let me first explain what is a degree. You all know, I still write the definition. Degree of an equation is the highest sum of power of variables of any single term. It looks a little confusing. Let's see, take an example, then you will understand. There is an example, 2x plus 3y equal to 8. So each one is a term. Hope you all have studied polynomial already in 8th standard. So this is polynomial, further we will be studying in 9th standard. But these are simple polynomials. 2x plus 3y, there are 2 terms. 2x is one term, 3y is one term. Each term means if whatever the values separated by a plus or a minus sign are called terms. So here x, power of x is 1, highest sum of power. Y is 1, so the degree is 1. So when we go to the next example, you will further slight changes will happen. Now you see 3x square plus 4y equal to 14. So here what happens? X square, that is x has got 2 power, y has got 1. So the degree is 2 here. The highest sum of the power is 2. I will explain to you why I am writing the word sum. When you see the next example, you will understand. Now you see a long equation. How many terms are there? 4x square y cube, one term, 3yx cube, second, 5y4, y power 4, third one, 2y is 4, 3x is 5. There are 5 terms are there. Let us see in each term what is the sum of the power. Now you understand sum of the power. Earlier in first 2 lines, you had only one variable in each term. Now you have 2 variables in the same term. So 4x square y cube is 2 plus 3, 5. 3yx cube is 3. 4y4 is 4. 2y is 1. 3x is 1. I hope all of you know this. I am still explaining to you. So the sum, you have to see everywhere sum. The third, fourth, I'll just mark this. Third, fourth, fifth, there are only one variable. But if you see in these two, in the same term, there are 2 variables. So wherever 1 is there, you can straight away take it. So the third term is 4. Fourth and fifth are 1 each. Now coming to the first and second term, this is 2 plus 3, this is 5. And this is 3 plus 1, 4. So the highest term is, sum of highest term is 5. So therefore here the degree is 5. Once again, hope all of you are able to understand this. So you have to take each term and see. So now the highest sum of power of variables of any single term. So every single term you should take, add the powers in each term and see which is the highest. So first one is 5, second one is 4, third one is 4, all others are 1, 1. So the 5 is the highest. Even though you can see that the third term has got, what is that? I'll change the color and show you. The third term is having 4 as the power, but still the first term is having sum is 2 plus 3, 5, even though the highest is 3. So we should not see the individual variable, we should see the sum of the variables. So very important point to note is the highest sum of the variables. Okay, now you can note down all these things. I will also erase all these things, and then again if you want you can note down the term, the definitions, everything. Then we will go to the next page. We'll go to the next page. So equations with 1 degree are called as linear equations. Linear means straight. Hope you all remember in the lines and angles we studied linear pair. Linear pair means in a straight line 2 angles are there, they are called linear pairs. So linear means straight. When we plot the values of variables of an equation with 1 degree in a graph paper, we will get a straight line. We will discuss this in a later part of this chapter. In this chapter itself we are going to discuss why it is called a linear equation. But what is a linear equation is defined here. That is when there is only 1 degree. So whatever we saw in the previous page, 5, 4, 3 and all, it is only for you to understand the definition of degree. But for this chapter you need not bother about that, because in this chapter you are going to have all the equations in only 1 degree. There will be only one variable. In each term there will be one variable, and the power of that will be only 1. Therefore, equations with 1 variable and 1 degree are called as linear equations in 1 variable. So in the previous 2 pages before we saw what is a 1 variable equation. In this page we are seeing what is a 1 degree equation, a combination of 1 degree and 1 variable, that is 3x equal to 4. I think we have given examples. Yes, some examples of the linear equations are like this. So x plus 1 equal to 0, x plus root 2 equal to 0, root 2y plus root 3 equal to 0. You can see in each and every equation there are 3 equations. There is only one variable x or y, and the power of each variable is not more than 1. So such type of equations are called linear equation 1 variable. And hope all of you remember this. You all know this, but still I have given detailed explanation. You can note down all these things if you have forgotten. Otherwise you can skip and go to the next page. So this one more. The value of the variable arrived at by taking the constants to one side is called a solution or root. That is, we will see again in the bottom. I will show you the variable, whatever value you are arriving at is called the solution. Solution for each of these equations is unique. Only one value for the variable is possible. Now you see what I have done. I have taken constants to one side, variables to another side. So what has happened? X plus 1 equal to 0 has become x equal to minus 1. So similarly you can go to that equation, x equal to minus root 2, y equal to minus root 3 by minus root 2. These are the unique solutions for these examples. That is, x and y will have only one value, which again we will be discussing why it is unique and what happens where you will get multiple solutions, that we will see in the later parts of this chapter. So here for one variable equation, linear equation with one variable, the solutions will be unique. There will be only one solution for each and every variable, and it is arrived at by taking constants to one side and variable to the other side. So I have taken the constants to RHS, variable to LHS. So you have got this answers, and I hope all of you know when you take one value to the other side, LHS to RHS, you have to change the sign. And if it is multiplication, division, the multiplication will become division, division will become multiplication. So solutions and number line. We can see some similarities between the solutions of linear equations in one variable and numbers on a number line. I'll just explain what is the drawing I have given there. We can locate the solutions of a linear equation in the number line as it is unique. So you know, in number line each and every point is unique, it has got only one value. So here x equal to minus 1 is 1 point I have mentioned, x equal to minus root 2 I have mentioned 1 point. So like this each and every solution can be located on the number line and it will be unique. Like linear equation has got only, each variable has got only one solution. Similarly, that each and every solution can be located on the number line. So here solutions we got for some of the examples, minus 1, minus root 2 are shown above. I have shown above. So what did we learn? In this video, we discussed that what all will be learning in this chapter. There are 3 things I told. That is, we will be learning what is linear equation in 2 variables. We will be seeing that in the next part. Then how to find solutions for 2 variable equations and how to draw the graph for 2 variable equations. These are the 3 things we will be seeing in this chapter. We recollected some definitions. That is, what is 1 degree and 1 variable. Sorry, what is linear equation 1 variable? We have understood 1 degree and 1 variable, and also in that process we recollected some definitions: constant, variable, degree, solution or root, and located the solutions in a number line which is unique. These are all we learnt in this part, and in the next video we will be seeing what is meant by linear equations in 2 variables and learn some properties related to the same. There are 5 questions as usual. Before starting these answers, understand this part thoroughly and then sit in a calm place. Sit for 10-15 minutes, close your book, close your notes, close the videos, and then attempt at one go, and then after that you can check the answers. That's all for this video. Thank you.